All right, so one of the big things in calculus is simplifying expressions. It's true. And so we're going to get some practice on that today. Here's a couple examples. If I asked you to simplify this, first of all, what does simplifying mean? Generally, simplifying means you want to condense down to one single term if you can. Okay, one single term. So that's basically some monomial or binomial, trinomial, whatever, over another one. That's one single term. That's okay. It's not always possible, but that's a good goal to try and have. And the reason why that is because if you have any factors that are the same, right, then you can divide those out. The other thing is to factor the top and the bottom if you can. That's another good rule. So try and condense them down to one single term if you can. Positive exponents, I guess that's another thing you want to look for. Positive exponents. The radicals, okay, so if you have, in previous math classes, you were told that a root sign in the denominator is not simplified. Generally, in calculus, it's okay to have radicals. Radicals, okay, can exist in the denominator, generally. Okay, so radicals are okay. So there may be more as we move through, but that's a good start point. So if we're going to simplify this, and the teacher says, let's say this is your answer, but you need to simplify whenever possible. Okay, well, that's not a big deal here. We've got 2 times 4x cubed. Now the 4 in here is not cubed. Okay, the brackets, the cube is not. We don't have brackets here. Okay, it's not saying that the 4 is cubed. So the 4 is just a regular number, which means that these brackets don't even really need to be there. It's like 2 times 4 times x cubed. See that? So we can simplify this to 8x cubed, this term right here. So that's good. Now this one over here, what did we say? Positive exponents, right? So we don't really want this negative there. And if you recall, if you have a negative exponent on a variable, how do you get rid of that negative exponent to make it positive? Yeah, flip it over 1. So if it's in the denominator, you move it up to the numerator. If it's in the numerator, like this one is, we would move this whole term down to the denominator. So this is 1/2 times x to the negative 1/2. So this whole x term, or this x variable part, would come down to the denominator with the 2. So it would be like this. And then that would make that a positive 1/2. Okay, so this right here, probably preferable to change this to a radical. So let's just rewrite this here. 1 over 2, and that, of course, to the power of 1/2 is the same as square root. Okay, so now this isn't bad. That's not bad, and you may, that may be just fine for an answer, and I would be okay with that. But you may see in the back of the book, if you're checking your answers, they may have something that's totally different, and you may think that you get it wrong, but maybe not. If the back of the book, simplifies it a little bit more, then you may actually have the right answer, but just not to the level of simplification that the textbook would have. So let's carry this further. If we want to carry this further, let's get to this one single term that I mentioned up here. So if we have 2 terms and we want to combine them, like if I want to actually add these terms, and this is apparently a fraction or a rational, what do you need to have when you want to add fractions? You need a common denominator. Very good. Okay. So if we want to do that, I have a 2 root x in this denominator, and right now over here I just have 1, right? So let's multiply this term over here, top and bottom, by 2 root x. And that means a 2 root x is to go up top there too. Now remember, when you're simplifying, that you can't just stick a denominator in there. You have to, in essence, multiply by 1, right? 2 root x over 2 root x is 1. And you can multiply anything by 1 and it won't change its value, right? So if you want a 2 root x on the bottom, like essentially out of nowhere, you have to accompany it with a 2 root x in the numerator as well. And I think maybe you need that. So now we look at these two. I should multiply these two together. And as a matter of fact, there's another level of simplification that we should be aware of. If you look at these are basically 2 radicals. This is x to the power of 1/2. This is x to the power of 3. So I'm just going to do this off to the side here. If this is x to the 1/2, and I multiply it by 8 times x to the 3rd, do you remember the rules that go along with this? You can multiply
5 over here will be 16x 5.
16x to the 5/2. Okay, let's see if you're right. You do multiply the numbers in front. The coefficients in front can be multiplied, so you're 16x. That's totally right. And when you multiply variable parts, if it's the same base, you simply add the exponents, right? So we've got 1 over 2. What is 3 expressed as a fraction over 2? Would that be 6 over 2? Okay? So that would be 6 over 2. So you would add these numbers here. So 1 over 2 plus 6 over 2 would be x to the 7 over 2. Okay?
I was thinking they were being divided, so then.
Yeah, right. No, yeah, that's right. No, not being divided, they're being multiplied, so you add. That's correct. So then this would be 16x to the 7 over 2 over 2 root x plus 1 over 2 root x. So we're getting close now, and what do we do now that we have the same denominator? We can simply add up all the terms that are on the tops of all of the rationals that have the same denominator. So we have 16x to the 7 over 2 plus 1 all over 2 root x. Now, the question is, are we done? Like, does this look like you can do anything more with it? And I guess what I'm asking is, can I do something with this 16 and this 2? Can I, okay, here's the question. Can I just say, hey, 16 over 2 is 8. Let's just change that to an 8 instead of 1.
You feel like part of the expression.
You're right, you can't do that. Because you're not touching this part of the expression. You're only changing half of the expression. Right? Yeah, not the whole thing. So you can't actually do that. So good. I was hoping you wouldn't say, yeah, that looks good, Mr. Maxwell. I was hoping you were going to say, wait a minute.
I made that mistake earlier today in physics.
Oh, yeah? Oh, is that right? You did that very thing today?
It was some complicated projectile motion question.
Yeah. Okay, well, here's the thing. Now, we do have a fractional exponent and a radical. I'm okay with it, but you might want to be a little more consistent here. So again, if the back of the book leaves it like this, great. If the back of the book, the answer key that you're looking at, might have this. And how could we change this x to the 7 over 2?
It would be square root and then the x across.
Square root x to the 7, right? And this 7 could be outside of the square root or inside here. So yes,
You
either
also
one.
take the radical on the bottom and change it to a fraction.
Well, you could change this radical on the bottom to a fraction. However, we don't want to do that because it's now it's pretty consistent. So yeah, so there's a big difference, isn't there, between this and, let's say, the in blue back over here, right? Look at back in blue there. Remember I said, yeah, that's you simplified that a little bit. But that if you had this as an answer, 8x cubed plus 1 over 2 root x, and you checked your answer, and it looked like this, you'd think, I screwed up, man. I did something wrong, right? But not the case. So simplifying is a big deal, and that's one good example. And you know what? We hit a lot of actually good things there, right? Common denominator, positive exponents, fractional exponents to radicals, negative exponents, consistency with radicals or exponents, that sort of thing. So there you go. That's good. That's one example there, and I hope that helps a little bit. Just one more thing, I guess, in simplification. If all your terms or most of your terms are negatives, you might want to pull the negative out, and that may be something that, one of the answers in the back might have. So the top, if you factored a negative out, would look like this. If you factored another negative out of the bottom, which you could, it would look like this. Because remember with binomials, if you change these signs here, right? So really, if I simplify that now, this is the same as that. All right. Okay. So that's the same. And again, you might think to yourself, God, I got something wrong. But it's not necessarily, no. There's just different factors.